The last time I was at a land management planning meeting, I was on the other side, on the Forest Service side, and that was actually when we made those false starts, 2006 and 7. No, actually it's 2005 and 6. Now I've been at ASU for 8 years, and so the other side. So it'll be interesting to know if I have more influence on this side than I did on the Forest Service side. So I'm going to talk about vegetation management, and you'll tell right away that that's what I'm trying to emphasize. I don't think that you can manage all these resources separately. We talked about ecosystems and managing for outcomes and not outputs, and managing for maybe functioning ecosystems instead of our individual benefits. But I'm still going to emphasize vegetation management. So, and some of my students really don't want to have anything to do with vegetation. They'd rather just deal with wildlife. And so, one of the things that I do, so I'm not trying to insult you all. I know you all know this, but one of the things I do is try to emphasize the importance of vegetation, and that it's one of those. It's the the starting place. It's the organism that receives the radiation from the sun and through photosynthesis produces the chemical energy that we all use as heterotrophs. And so vegetation is very important. The first step in actually providing the food that we need, the food that wildlife needs, the habitat that wildlife needs, cooling of the Earth's surface, all these important things that vegetation provides. Through evapotranspiration, it causes percolation of water into the soil, so it's important in the hydrologic cycle and of course all the other nutrient cycles. And so I know that you're convinced of that. I'll go on with my ideas as far as vegetation management goes. And when I talked to Ed first about this, I had all kinds of ideas as far as vegetation management, but I really want to narrow it down to, since we're in the Sonoran Desert, and the Mesa district, or this area is more influenced by the Sonoran Desert, I wanted to narrow it down to the Sonoran Desert and maybe some threats or concerns with vegetation management in the Sonoran Desert, recognizing that there's all kinds of different vegetation types on the forest, but I know you'll talk more about fire and ponderosa pine type ecosystems when you go to Payson and maybe Pleasant Valley, and some of the range issues probably in Pleasant Valley. But anyway, I want to talk overall a few threats, I think, to vegetation, and then narrow it down to the Sonoran Desert, some of the work that I did in the Sonoran Desert. But anyway, threats overall to vegetation. I look at one of the major threats that hopefully will be recognized as just losing public status, or losing lands that are in the desert for development. Yeah, and I know that takes an act of Congress, but that can be done too, sometime in the future. And so I know that when I first moved to the Tonto, just kind of getting out of that the idea that desert lands were pretty much a wasteland. And so if there was a need to do any kind of land swaps, like if the Coconino needed some land that was adjacent to their forested, ponderosa pine forested land, and they were trying to acquire that, whether it was state land or whether it was private land, well, they trade off some of the desert land and convert that to private land, and we'd win because we got this good ponderosa pine type lands. But so there is. That still could be a threat as far as trading land and losing status of valuable land, and developing that land to other uses. And then the other thing is poor management, which covers lots of things. And sometimes poor management due to a misunderstanding of ecological disturbance regimes and causing a change in vegetation characteristics. And so a good example that everybody knows about and it's been talked a lot about is just our idea of ponderosa pine when Europeans settled the area, the idea that fire's bad, and go to whatever extent is needed to protect these type of ecosystems from fire, and not realizing that, you know, there's only so much precipitation and there's only so much capability and nutrients in the soil to grow a certain number of trees per acre. And so there was this natural mechanism that kept the numbers of, or the density of these trees in check, and that was fire. Fire was a natural disturbance that kept the numbers of trees in check with the climatic conditions and the capability of those lands. So those are some things that we didn't understand, and I know the density of trees got to be such that now we're dealing with that. And forest health decline, bark beetle populations, or sometimes bark beetle outbreaks cause some problems and drive the live fuel content down enough to where we had some real fire conditions. So anyway, didn't want to get hung up on that. So I want to go on with, so I talked about, I'm not going to talk about ponderosa pine ecosystems or chaparral woodlands. I'm going to talk more about Sonoran Desert ecosystems. And to talk about that, I want to emphasize the importance of managing vegetation, especially invasive species, and the effects of fire because of invasive species, in some cases in the Sonoran Desert. Okay, so anyway, the Sonoran Desert is unique to this area. It's unique to southeastern California, southwestern Arizona, and of course northern Mexico. The Sonoran Desert is pretty well takes this, pretty well straddles the Sea of Cortez, and it's a subtropical. Well, most of the vegetation is, well, the typical vegetation in the Sonoran Desert is subtropical, and so you don't find the same vegetation anywhere else in the world. You know, especially when we're talking about Arizona upland subdivision, the saguaro, palo verde type plant communities, which is this subdivision right here that we have a lot of on the Tonto. So the way that developed, the way that vegetation developed is that there was tropical vegetation that over geological time, the glacial periods and interglacial periods, over hundreds, thousands of years, then the subtropical vegetation would move north during the interglacial periods and then south during the glacial periods. And so that caused this development of these specific vegetation characteristics, which adapted and evolved here in this area. So we have the coastal mountain ranges that keeps it dry in the Sonoran Desert, and then just the location as far as distance from the equator, of course, keeps it warm and dry. So anyway, it's an important vegetation community, an important ecosystem. The Sonoran Desert is about, just guessing, 300,000 acres on the Tonto, mostly Arizona upland subdivision, which is kind of skirts this part of the Tonto. So anyway, some of the threats to the Sonoran Desert vegetation is the loss of diverse native Sonoran Desert vegetation, which is adapted, that has adapted over thousands of years, and so that by evolving with these climatic conditions, then you would assume that that's the most adapted plant community. It's the most diverse. It's the most resilient, and it's be the most productive for this particular climate. So we want to keep. That's why we like these native plants. We want to keep these native plants that have evolved with these climatic conditions. So threats to that would be invasive plant species and fire. And sometimes in the Sonoran Desert, the invasive plant species have the potential to change the fire regime. And so that's a threat to the Sonoran Desert. So some of the things there's more plants than this that are a threat to the Sonoran Desert as far as changing the fire regime. Buffalo grass was mentioned a while ago. And then red brome is an annual grass that is a threat, especially here on the tidal. Buffalo grass is starting to move, become a threat too. So this is buffalo grass. I just threw this in. This is lower Sycamore Creek, and so some of the ATV use in lower Sycamore is a process for spreading some of the invasive species also. This is an unmanaged area. So I just listed some of these. This is by no means all the invasive plant species on the Tonto. I listed some of the most notorious species, grass species, especially for changing fire regime. These are species that are adapted to fire. They do well with fire. Bromus rubens, as I said, is an annual brome grass that I started seeing. Well, when I first came to the Tonto, I guess it's probably existed back in the 1950s, but really started to increase during the 1980s when kind of a wet decade, and then of course it's everywhere in the Tonto now. A Eurasian grass. It came. The belief is that it probably came. Stopped in California first, and came over with different kinds of processes with cattle, with hay sometimes, and then just with seed. And so red brome came over and became pretty prolific on the Tonto. Buffalo grass, Pennisetum ciliary, is when I first came to the Tonto, I hardly ever saw any buffalo grass. I saw some fountain grass, quite a bit of fountain grass, but not very much buffalo grass. Now, and it was a big problem around Tucson, and now you see a lot of buffalo grass. Kind of looks like it's basically moving its way up the B line and I-17. So you see it quite a bit now. It's a perennial grass. So the reason it's a threat is it's a perennial grass, and it's fire adapted also, and so it's very competitive against other species, native species. And then Avena fatua, another annual grass that we see in some places. Actually, Avena fatua, I took some students to. I don't know if Art's been out there, or maybe you've been there too on the old Superstition grazing allotment. One of the clusters, C3. It's actually on Black Mesa. That's where it's located. And so we went up there, and that Black Mesa is covered with Avena fatua now. And looking at the old photos from 1954, there was no Avena fatua. Of course, there wasn't much of anything in 1954. It was pretty heavily grazed. But then in 1974, you started to see some of the Avena fatua, and now there's tons of it. So Avena fatua could be a threat. And one thing about Avena fatua is it's not all, it depends on how much moisture you get. So this year there's not as much up there, so it's better than last year at least. Buffalo grass. Once buffalo grass gets established, I don't think any low amount of moisture would cause it to drought out. Okay, so anyway, by no means that doesn't cover all the invasive species on the Tonto that that should be concerns with. Lots of Sahara mustard and salt cedar and all kinds of different species that you be concerned with. But I was looking at the ones that really have an impact as far as changing the fire regime in the Sonora Desert. So I did a study back in 2000, about 2000, 99 to 2000, and was looking at the effects of fire on the Sonora Desert plant communities. When I first got to the Tonto, it was back in 1991, and it was actually, when I got there, it was following some years that were fairly wet winters as far as precip goes, and so there's big production of red brome. I didn't really tie the two together very well at that time, but I did know that there was lots of fires. Lots of Sonora Desert fires on the Tonto, and so I was concerned with that, and I wanted to see what is it that's causing so many fires. Is the numbers of fires actually increasing on the Tonto, And are the numbers of acres, the size of fires, are they also increasing over time on the Tonto? So I did a study to look at that. And I know that, and looking at this, we know that these kinds of species, the saguaro and these, even Troya, Palo Verde, a lot of the succulent species aren't adapted to fire. We know that. They're not fire adapted. And so if they're not fire adapted, and those are the species that characterize the Sonoran Desert, then logically fire wasn't a big part of the long-term evolutionary history of the Sonoran Desert. And not only that, the interspaces, natural conditions of interspaces were that interspaces were pretty bare unless you had a fairly good monsoon season, or even sometimes a wet winter. Sometimes you'd have the native annuals that would grow in these interspaces, and then there's a whole interesting cycle there. They seem to decompose and provide these nutrients that wash in under the shrubs, and that's kind of an interesting process that goes through to provide to concentrate nutrients to the plants that are growing. But anyway, they decompose quickly. Red brome doesn't decompose quickly. It grows in the interspaces, and the skeleton stays, and it's primed for, when the spark is there, then fire spreads pretty fast. So anyway, my point is that fire was not likely part of the long-term evolutionary history of the native vegetation in the Sonoran Desert. But we know that I looked at fire records on the Mesa district. They had a good set of fire records from 1955 in the Sonoran Desert. And so I looked at those records from 1955 to 2000, and saw that numbers of fires, of course, increased pretty quickly. Something that's kind of interesting that we figured out is sometimes if back in the 1950s at least, if there was a fire, Mesa and Cave Creek is in the Sonoran Desert, sometimes they just kind of let it in. Say, well, it's not in the Ponderosa Rosa Pine, so we're good, just let it burn. Unless it got close to Apache Junction or something, they would suppress it. But sometimes it wasn't because there wasn't any fires. They either weren't detected, or they just kind of didn't report them. But anyway, in any case, there was a sharp increase. In the 1980s was that decade that was fairly wet, or very wet compared to previous decades, and even since then. So we had an increase in the 1980s, and then sort of a decline to 2000. And I'm not sure I can completely explain that, except that I think that public awareness became, people became more aware of what fire problems. The population was growing in the metropolitan area, and they were more aware of that. Burn barrels were outlawed at Apache Junction, and those kind of things probably caused that decline over time. Something that's interesting, though, is fires. The numbers of fires increased over time. The size of the fires didn't necessarily increase over time. They increased with whether or not there was a production, whether or not there was a wet winter, and especially 2 wet winters back to back. And those 2 wet winters back to back caused a crop of red brome. Red brome grows really fast. Red brome germinates really completely. 97% of the seeds germinate with red brome in the first 2 or 3 years, or the first year actually. And so it germinates quickly. If there's 2 dry years, then there's really not much of a production of red brome that first wet winter. But if there's 2 wet winters in a row, then there's 1 wet winter produces seed, and then the second wet winter produces biomass, and so you have a fire here that following summer.